Today's video is the third video in my series where I migrate my entire home network over to run purely on MikroTik hardware. And in this video, we'll be tackling the Wi-Fi by installing 3 of these MikroTik CAP AX access points. But first, I'd like to thank MS-DIST for sponsoring this video by providing all the hardware you see here. MS-DIST is an official distributor and reseller for MikroTik and other brands including Ubiquiti and Teltonika. They offer competitive pricing, including special pricing for trade customers, have received great customer reviews, and have product experts available if you need an extra hand picking the right product or after-sales support. So, if you're interested in buying any of the hardware you see in this video, or any other networking hardware for that matter, definitely check them out, and I'll leave links to all the products shown in this video along with a discount code for MS-DIST in the video description and in the pinned comment. Currently for Wi-Fi, I'm using a single Ruckus R650 access point, but now that I've moved into a much bigger place, I now want to have a few different access points spread throughout the house. And since my plan here is to do everything using entirely MikroTik products, I've gone for 3 MikroTik APs, and in particular, the CAP AX, which you can just about see there. As the name suggests, this is a Wi-Fi 6 802.11ax access point. So nothing particularly bleeding edge like Wi-Fi 6E or 7, since MikroTik don't yet offer any of those, but realistically, most of my current devices top out at Wi-Fi 6, so it'll be fine for now. However, as soon as MikroTik release any Wi-Fi 7 products, I'll absolutely be checking them out. The term CAP in the model number refers to these being ceiling access points. However, they also offer other form factors such as their WAP series, which are weatherproof models, MAP models, which are tiny pocket-sized portable models, HAP models, which are more of a traditional sort of home router type form factor, and since all of these run MikroTik's Router OS operating system, they can either work as complete wireless routers or pure access points. Then when you use MikroTik devices as access points, you can either configure them to work completely standalone or use the CAPsMAN feature of Router OS to act as a wireless controller to a bunch of access points. You can either run CAPsMAN on a separate MikroTik device, which is what I'll be doing with my RB5009 router, or you could just run it on one of your access points, similar to how things like Ruckus Unleashed works, albeit without the automatic failover between APs. We'll take a more in-depth look at the software later, but first up, let's take a look at the hardware. So here we have one of the access points. It's a pretty large device, and while it's not the most stylish access point out there, it doesn't look too bad. On the front of the access point we have an LED, and this also contains a button which by default turns the LED on and off, but you can also configure it to make this trigger script within Router OS. Not quite sure what I'd use it for, but hey, it supports it in case you need it. Then around the back, we have a pretty simple mounting bracket. It just slides off like that, and it's a little plastic plate that you can slide off the access point, like that, screw it onto a ceiling or something, and then clip it back in, so it should be pretty easy to mount, and we'll take a look at that later in the video. Then, in terms of connectivity, we have a pair of gigabit Ethernet ports. One supports 802.3 AF and AT PoE in, and the other supports passive PoE out. So you connect your the PoE in port into your PoE switch to connect it to your upstream network, and you could use the other port to connect some sort of other downstream device. Now, I wouldn't necessarily recommend wiring a building with the expectation of connecting a device to the second interface of an access point, but it could be useful in a pinch. Now, it's a bit of a shame that these are only gigabit ports, since a lot of Wi-Fi 6 APs will have 2.5 gig ports, but realistically with Wi-Fi 6, it's only really beneficial with a large number of clients, since you'll struggle to get a single client beyond 1 gigabit. Especially on a device like this that only has 2x2 MIMO, 2.5 gig on Wi-Fi 6 really only becomes important when you're dealing with a lot of clients and a 4x4 MIMO access point. When you're dealing with single clients, 2.5 gig only really becomes beneficial when you're talking about things like Wi-Fi 7, since with that, you can easily get beyond gigabit with a single client. Then, finally next to the network ports, we have a reset button and a DC input, which you could use instead of PoE if you prefer. Then in the box, it also includes a power adapter and also a PoE injector, so you could use this if you'd rather use this instead of a PoE switch. Now, of course, like a lot of MikroTik products, this does have a Euro plug, but if you want to use it in the UK, MS-DIST did include a UK to Euro plug adapter. And it's actually one of those nice ones that you can plug it in there, and it actually has a screw on the bottom you can tighten up, and it actually locks the adapter onto the plug, so it kind of makes it one big unit. So at least you've got that if you need it and if you want to use it with a PoE injector, but I'm going to use it with a PoE switch, so that's not going to be a problem. Then along with that, it also includes this bracket here, which you'd use if you're mounting it to a ceiling tile. You'd put this above the ceiling tile, screw the plastic bracket below the ceiling tile, and screw through into here. And all it does is just spreads the weight out on top of a thin sort of polystyrene ceiling tile to stop it cracking, so you'd use that if you're mounting to a ceiling tile. Obviously I'm not, but comes with it if you need it. So, that was a tour of the hardware. What we'll now do is we'll take a look at the software side of things, get one of the APs set up and added to CAPsMAN, and then we'll go and get them installed in the ceilings around the house. So now, let's take a look at the software side of things. Now, I'm not going to go into a full setup tutorial, as MikroTik already have pretty good videos on that, but I'll run through the basics of the configuration I've already set up. As I mentioned earlier, these access points run the full RouterOS operating system, so you can configure them as completely standalone APs or even use them as full-blown routers. And to do that, you just need to log into the management interface on the AP itself, either using Winbox, a web browser, or over SSH. However, since I have multiple APs, I want to be able to centrally manage them through a single controller, and for that, MikroTik offers software called CAPsMAN. CAPsMAN is a feature of RouterOS, and therefore it can run on any RouterOS device. So you could run it on a MikroTik router, run it on a MikroTik switch, RouterOS running on some sort of x86 PC hardware, or even run it on one of the access points itself, and use it to control the rest of them. For my setup here, I'll be running it on a MikroTik RB5009 that I'm using as my main router. So here we are logged into the RB5009 using Winbox, and on the left hand side here we have a pair of options, one for Wi-Fi and one for wireless. And this can get a bit confusing, so let me explain. Back in the day, the wireless section is where you configure everything to do with Wi-Fi in RouterOS. And under here there's two different options. One for wireless, which lets you configure the wireless interfaces that are internal to the device, and one for CAPsMAN, which lets you set up the controller to manage remote APs. However, when MikroTik started developing support for Wi-Fi 6, they presumably ran into issues with the old software and rebuilt the Wi-Fi software from the ground up. And this new software is what you'd find under the Wi-Fi menu. So with this, if you're configuring a Wi-Fi 6 device, you'll use the Wi-Fi menu. If you're configuring an older device, you'd use the wireless menu. The only exception is some of their 802.11ac devices, which can be updated to work with the new software by installing the Wi-Fi QCOM AC package. So just bear this in mind so you don't get confused and configure the wrong section. And also remember that this means that if you want to manage a mix of modern Wi-Fi 6 APs along with some of their older APs, you'd essentially need to run both versions of CAPsMAN in parallel. So since everything I'm doing here is Wi-Fi 6, let's go into the Wi-Fi section. And in here we can see the configuration. Whereas previously the configuration for any local Wi-Fi interfaces and the configuration for CAPsMAN were in separate sections, with the new version it's all configured through this one area. The first tab we have here is the Wi-Fi tab, and this will list any wireless interfaces present in your device. But since the RB5009 I'm using as a wireless controller doesn't have built-in Wi-Fi, this list is empty. However, once you set up CAPsMAN and connect some APs, your AP's interfaces will also show here labelled as Managed by CAPsMAN. Then on the next tab, we have the configuration. And this is where you'll create configuration profiles for each of your wireless networks. These can then either be assigned to local wireless interfaces or be pushed to access points managed by CAPsMAN. You can see here that I've created a few different networks for testing. One for my main LAN on VLAN 1000, so we can go into here and we can show VLANs. So add VLANs to the list. There we go. So we have one for my main LAN on VLAN 1000 and the other for guests on VLAN 1001. You can see that I have a pair of different configuration profiles for my LAN on both 2.4 GHz and one for 5 GHz, and I'll explain why shortly. But if we go into this, we can see we have all the configuration we'd expect. The SSID, the country, the security settings under here, and then other settings in here for channel. All the sort of stuff you'd expect. The only catch here is where most APs would let you pick a list of numbered channels. On MikroTik you actually need to enter the frequency. So that might just take a bit of additional Googling, since you probably don't know that off the top of your head. Then if we close out that, next up, all the tabs from channel to access list let you create more specific configuration profiles, which you can then assign within multiple of your main configuration profiles to save duplicating the same config all over the place. So for example, if you create a security profile on the security tab, you could then go into each of your configuration profiles, so say here, and then you can pick the security profile from this list to apply those settings. For example, I have a security profile here that enables the 802.11r fast transition, and it also disables WPS. So I've created that one configuration there. I'm then coming to my configuration profile, pick that, and that applies that across all my SSIDs rather than needing to duplicate it into each of them. So yep, that's what all the tabs between channel and steering do. Then next up we have the registration tab, which will show clients that are connected to the access points. The access list tab that lets you configure access control rules such as MAC address restrictions. Then next we have the provisioning tab, and this is where we assign the configuration profiles to be deployed to the access points. And if we go into one of these, we can pick one of our configuration profiles as the master configuration, and then we can add the rest as slaves. Then there's a bunch of other stuff in here as well to filter what IPs the profiles are pushed to, and so on. Now, you may notice here that I have a pair of separate entries under provisioning for 2.4 and 5 GHz, along with a pair of separate configuration profiles over here. And they're specifically for my LAN network. Now, technically, you don't need to do this, and it'll work fine picking all the channels to use automatically. However, by default, this will use a 40 MHz channel width for 2.4 GHz, which is a bit too wide for my liking. But if I was to have a single configuration profile and pick a 20 MHz channel width, this would then apply to both the 2.4 and 5 GHz interfaces, which isn't exactly ideal. So instead the solution is to create two separate profiles, one for 2.4 GHz and one for 5 GHz, each with their own radio settings, but give them both the same SSID, VLAN and security settings. Then it works absolutely fine. It shows up as a single SSID, allowing the client to connect to whatever band they prefer, but each radio will have its own settings. It's also worth bearing in mind that then on the provisioning tab, where you assign these configuration profiles, it will only use the radio settings from the profile picked as the master configuration. This means that we only need to duplicate the profile we're going to use as the master, and for the rest of the additional networks we can get away with just having a single profile and leave the rest of the channel configuration in that profile blank. Then on the provisioning tab, all we need to do is set one of the configuration profiles to assign the 2.4 GHz master configuration to the 2.4 GHz band, and then the other one needs to assign the 5 GHz master configuration to the 5 GHz band. And then for all the additional SSIDs, we just have them set up under slave configurations. Now, the only other tricky bit I found here is when it comes to assigning Wi-Fi channels, since I can't find any way to specifically assign different APs to different channels. If I set a channel in any of the configuration profiles over here, it will put every AP on the same channel, which may not be ideal for your situation. The only way I can figure out a way around this would be to similarly duplicate your master configuration profiles so that you have several, each with different channels set, and then assign those to subsets of your APs on the provisioning tab, which could get pretty messy. Now, you may also be able to build some sort of custom setup with router OS's scripting, but it's not something I've looked into in any detail. That said, by default the APs will automatically scan and pick whatever channel seems clearest, so that should be fine for most situations. The only thing to watch out for is I've seen reports where people have said that if all the APs power up at the same time, they can sometimes end up scanning at the exact same time and pick the same channel as each other. The solution to this is to define a reselect interval, which defines how often each AP should perform a new channel scan. By setting a range in here like I've done, each AP will rescan for clear channels after a randomly selected delay between 12 and 24 hours. This means that the likelihood is that APs will scan for channels at different times to one another. Then all that's left is the Remote CAP tab, and this will show a list of all the APs being managed by CAPsMAN. And then this CAPsMAN button over here lets you enable the CAPsMAN service along with some additional options, such as if you want to require APs to present some sort of certificate, or what I have here is I have it configured that CAPsMAN only listens for APs on my management VLAN. In here I've also set it up to suggest to my APs to update the firmware to the same version as the CAPsMAN controller. And this path here points to a directory on my router that I've uploaded the update packages that will be sent to the APs. Now, the final feature I want to talk about is something that I really like in an access point, and it's the Multi-Passphrase feature. This is something that several other access point vendors have introduced over the last few years, and they each call it something a bit different. Ruckus call it DPSK, Ubiquiti call it PPSK, Aruba call it MPSK, Cisco call it IPSK, and MikroTik call it Multi-Passphrase. However, all those basically do the same thing, and that is that they allow you to assign multiple different keys to a single SSID, and the key that you use will define which VLAN your device is placed on. This is a super useful feature if you want to heavily segregate your network. For example, on my network, I have separate VLANs for LAN devices, guest devices, IoT devices which require internet access, IoT devices which should not have internet access, cameras, management traffic, and so on. Setting each of these up with their own SSID isn't particularly good practice, since each AP will need to broadcast beacon frames for each SSID. And since beacon frames are transmitted at very low data rates in order to support slower clients, they take up a fair chunk of the total airtime on the channel. If you start adding a ton of different SSIDs to a large number of APs, you can easily end up with a situation where the number of beacon frames congests the channel so much that your actual usable data throughput can noticeably suffer. And no, hiding the SSID won't do anything, as your APs will still send out the beacons, they just won't contain the SSID itself. Tall Paul Tech on YouTube has made a great video showing this in action, so I'll leave a card on the screen if you're interested. So, this is where Multi-Passphrase is super useful, since it allows you to broadcast just a single SSID that all your clients connect to, and you can use the keys to separate those clients onto their respective VLANs. So to configure this, we first go to the Security tab, and on the right here we click Multi-Passphrase Group. Then in here we define each of our keys and their respective VLAN ID. The name field here is used to bundle these sets of keys into groups, which can be assigned into configuration profiles. Currently I only have one here, called PPSK with a pair of keys, but you could define multiple groups if you want to have multiple SSIDs, each with their own set of keys. Then we also have a couple of additional options: isolation, which enables client isolation between clients on the same AP using that key, and expires, which allows you to set a time for the key to expire. And this is the second great use for this type of technology, and that is that you can easily create a bunch of temporary keys that expire after some time. And with RouterOS's scripting functionality, you could probably even automate that or integrate it with an external system. Then, once we've created our multi-passphrase groups, we can go into the configuration profile for our SSID, so configuration, the PPSK SSID. Then in the security section, we want to pick WPA2 PSK, and rather than setting a passphrase in here, we instead want to pick our multi-passphrase group from this drop-down. And that'll work fine. There's only a couple of catches that are worth bearing in mind with this. The first is specific to MikroTik, and that is that you can only use VLANs with multi-passphrase on the newer Wi-Fi 6 access points. You can't use it with the older Wi-Fi 5 access points that have been updated to support the new Wi-Fi package. The second catch applies more generally to this type of technology, and that is due to the way that WPA3 handles encryption, this type of technology isn't supported, meaning that you're stuck with WPA2. Now generally this isn't a huge deal, but the downside is that when it comes to 6 GHz, WPA3 is required, meaning that you can't use this sort of thing with 6 GHz networks. Obviously right now these APs only go up to 5 GHz, so that's not an issue for me, but in the future once Wi-Fi 6E and Wi-Fi 7 are more widespread, I'll probably end up using some sort of hybrid approach where I have a WPA3 6 GHz network for my main LAN with its own key, and I configure a second 5 GHz WPA2 network with multi-passphrase enabled for devices that I want to segregate onto different VLANs. The only exception to this is Ruckus, who now support what they call DPSK3, which sort of gets around this, but it involves the client first connecting to the 5 GHz radio using WPA2. The access point then does something that Ruckus described as patented Canadian magic to remember what key the client used, and then the client can reconnect to the 6 GHz radio using WPA3 and be assigned the correct VLAN. So yeah, while long term this type of technology may not be suitable for every SSID, it's still a great option for segregating things such as IoT devices that don't need or even really support 6 GHz or WPA3. Of course, another option to have a single SSID and assign clients different VLANs is to use WPA Enterprise. And this is definitely a great option when you're only dealing with things like computers and phones. However, when it comes to things like IoT devices and even some smart TVs, those often simply just don't support it. So it's not really a viable alternative in a lot of cases. But after all that rambling, we now have everything configured. So now let's try and provision an access point with this controller. So now let's plug the AP into my network and get this set up. This port here on the wall is connected to my PoE switch, and it's already configured with the appropriate VLAN configuration that I need for an access point. And as you can see, the AP is now booting up. The light on the front's very hard to see under the video light, but it is lighting up, as is the network LED on the back. So we can just let that boot up. So the AP is now booted up. However, in its standard out-of-the-box configuration, this is actually acting as a router, with ETH1 acting as a WAN port and ETH2 acting as a LAN port, and it's performing NAT between them. This also means that you can only initially get to the management interface by connecting to ETH2, so it's a bit weird since I'd have expected this to come more configured as an AP out of the box rather than a router, but if you did want to use this as a standalone AP, you would just need to connect the management interface on ETH2 and reconfigure it to disable NAT, disable the DHCP server, add all interfaces to a single bridge, and then configure the wireless interfaces. But of course, that's out of scope of this video since we'll be configuring this to be controlled by CAPsMAN. So to do this, we need to switch the AP into what's known as CAP mode. We can either do this by logging into RouterOS on the AP and ticking the CAPS mode button on the configuration reset screen and then clicking to reset the configuration, or we can do what we'll do here and enable CAPS mode by using the reset button on the AP. So to do that, we just need to unplug the AP, hold down the reset button, which is hard to do when you're holding the cable in the wrong hand. So hold down the reset button, and then plug the power back in. Now the LED on the front will come on solid and then start to flash. So it's now flashing after a few seconds, and then we keep holding the button until the LED goes solid, and then we let go. And now that'll start up in CAP mode. So we'll let that boot up and we'll provision it. And now here in RouterOS, we can see that the access point is now showing up on the remote CAP tab. Now this already seems to have automatically provisioned itself and updated itself to the latest firmware. Previously in my testing, I think I had to click the AP and then manually click provision, so I'm not sure if either I didn't need to do that previously or the access point is, this one's maybe previously been used in my testing, so it provisioned automatically. But now the AP is provisioned, it's updated itself to the latest firmware, And then if we come back over to the Wi-Fi tab, we can see all the wireless interfaces that are coming from the AP. So as you can see here, we've got all the Wi-Fi interfaces, the 2.4 GHz down here, the 5 GHz up here, which is currently doing a DFS availability check. This is because, if you didn't know, some Wi-Fi channels are called DFS channels, and they're the same sort of frequencies that are used by things like radar. And what the access point, if it's using a DFS channel, has to do is wait when it powers up, scan for any potential things like radar on that frequency, and it's only allowed to broadcast if it doesn't find anything. So that's why with some 5 GHz access points, they'll maybe take a couple of minutes before the 5 GHz starts after they power up, and it's because it's doing a DFS scan. So as you can see, that scan is now complete, and all the wireless interfaces are now up. So we can see we have them all here. We've got the 5 GHz ones, 2.4 GHz down here, and each of them has a couple of virtual access points as well, because these are the additional SSIDs. So yep, that's now all working. So we can see we have all our SSIDs there. We can scroll along here, we can see that's the SSIDs for each of those radios, and these are all the radios for each of the access points. So right now I've only got one access point, so we have the 6 radios, or 2 radios and then 6 SSIDs from this access point. If we added more access points, they'd all start to show up under here. And if we scroll onto the side here, we can see there's a channel, so it's picked some channels automatically. So now let's try and connect to this. Okay, so now that we're all up and running, let's take a look at it working. So as you can see right now, my phone is connected to the main MikroTik LAN SSID, and therefore because it's on my main LAN, it's got VLAN ID of 1000. So what I thought we'll do is we'll take a look at the PPSK, or multi-passphrase functionality, just because that's really the most interesting thing you can show when you're connecting a phone to Wi-Fi. Everything else is a bit boring. So what we have here is in the terminal down here, I've printed out my two multi-passphrase keys. We have the one for my LAN network, which is LAN_MKTestPass exclamation mark, and that's VLAN 1000. And then we have guest _MKTestPass exclamation mark, and that's VLAN 1001, which is my guest network. So as you can see right now, my phone is on the LAN network with VLAN ID of 1000. So if we connect with the password of guest _MKTestPass exclamation mark, that should connect my phone to the guest network. So if we press connect on the phone, and here you can see the phone is now reconnected very, very quickly actually, and it's now on the MikroTik PPSK SSID, and it's got a VLAN ID of 1001. So that's worked. I've been able to use the guest key on the PPSK network, and it's dropped me onto the guest VLAN. It works perfectly. And what we can then do is we can come into the phone, we can then forget the network, it will disconnect me, I'll then enter, and as you can see my phone's now reconnected back to the main LAN network, and now what I'll do is I'll try and log in to the same network, this time using the LAN passphrase, so LAN_MKTestPass exclamation mark. So now on the phone we're entering the LAN pre-shared key for the same network. Press connect on that. Yep, and there we go. As you can see, I've now connected, and the phone is now connected to VLAN 1000, but still on the same SSID. So that works. So yep, all that's working. My phone connects completely fine. It's getting the correct VLAN ID. It's on the 5 GHz band, which is what I'd want it to sort of steer towards 5 GHz. I'm getting transmit and receive rates that I'd expect for this kind of setup. So now, let's run downstairs and get the access points installed on the ceilings. Okay, so now it's time to install the access points. So right now, here we are in the living room, and I'm going to put the access point up in the corner here, somewhere up on the ceiling. And when I cable the place, I've already run a cable to this location, and it's coiled up above the ceiling, and above here is a fitted wardrobe where I've got an access panel on the floor I can lift up, so I can easily access the cable and poke it down through the ceiling. Similarly, on the upstairs landing, I've got the cable coiled up in the attic, so again I can just drill through the ceiling and poke the cable down. And then in the kitchen, because there's already a bedroom above that with furniture and carpet already installed, I couldn't really lift the floor up to pull the cable down. So what I've already done a bit before the carpets went down is I've poked that cable through the kitchen ceiling, so it's sitting there ready to terminate. So all we need to do now here in the living room is drill through the ceiling, get the cable pulled down, and we'll talk about how we're going to terminate it. And there we go. So I've now pulled the cable through the ceiling, so now let's terminate it. Now when it comes to terminating a cable like this into the back of an access point, there's a couple of options you could do. The first and probably most commonly done one would just be to crimp an RJ45 connector directly onto the cable. And that does work, and especially if you're using Cat5e or Cat6, generally it'll work fine, you can crimp it on, and the cable's usually flexible enough that you can still sort of bend it into the back of an access point. However, with my install here, I'm using Cat6a, and it's a very thick, stiff cable. This is Cat6a U/FTP, so each pair has its own foil shield around it. The cable's very thick, and it would be really awkward to terminate into an RJ45 plug. You possibly could do it, but you'd really be squeezing it in there. And generally for Cat6a, the recommendation, rather than using a sort of simple crimp type connector, is to use what's known as a field termination plug, which terminates more like a keystone jack in that it has a PCB inside it and proper IDC terminals that you crimp the cable down into. Those do generally work a lot better, but the downside with those is that the plugs are physically quite large, and I'd probably struggle to get it into the back of an access point. Therefore, instead of doing that, what I'm going to do is I'm going to terminate this run into a regular keystone jack. So this is a Cat6a keystone jack, like I've used throughout the rest of my install. I'll terminate this onto the cable, and then I'll run a short patch lead from the keystone jack into the access point. And then the whole bundle can be pushed up into the ceiling out of the way. That way I can use a really nice thin flexible patch lead into the access point, meaning there's loads of space, no sort of tightly kinking cables around and bending them into the access point. I can obey the appropriate sort of bend radius and all the cables and all that sort of stuff, and it should just work a lot nicer. Also, when it comes to testing, if you're using something like a proper cable certifier, generally those will expect each run to be terminated in a regular female jack. If you've got a plug crimped onto the cable, you can certify it, but with those certifiers you need to use special MPTL or modular plug terminated link adapters, which I don't have for mine, so that's another sort of benefit as well. So let's get this jack on and get the AP installed. So there we go, that's the keystone jack now installed. And I explicitly use this type of keystone jack that has a bit to let you put a cable tie around to secure the cable, rather than the low profile type I tend to use, just because this cable tie also sort of provides strain relief, so if the cable gets moved around, because obviously it's not fixed into anything, that shouldn't pull out. And then I've also been able to test it with my very, very old certifier, but as you can see, that is fully certified to Cat6a standards. So, yep, that's working. And there we go, what I've now done is I've now connected the patch lead up, so I've used a very slim Cat6a cable, could just be Cat6, just the Cat6a one was the same price. So it's one of those very slim, super flexible ones, so that'll be super easy to get into the bottom of the access point. And then I've plugged that into the keystone jack, also labelled it up. And then what I've also done here is I've made a slight contraption out of cable ties. And essentially all this does is I've just got one cable tie around the Cat6a cable, one cable tie around the patch lead, and then a cable tie between them, or two, because they weren't long enough. So the idea is that this just keeps these two connected together, so there's no way they could end up pulling apart. The reason is that when I shove this up above the ceiling, what I don't want in the future is if I ever try and pull it down for maintenance, say the clip on the Cat6 on the patch lead gets caught, it unplugs, pops off, and then the keystone jack pings up and it ends up stuck inside the ceiling. Because obviously here, unfortunately, I do kind of have access from above, but in the kitchen, if this got lost in the ceiling, it would be a bit of a nightmare. I'd have to basically take the floor up upstairs or cut a hole in the ceiling. So doing this just kind of keeps the two sort of securely attached together so they can't come apart. So what we can now just do is push this up into the ceiling, just leave just the patch lead hanging out, and get the AP mounted. So there we go, that's the cable now pushed back up into the ceiling, so we've just got the cable coming down here. Then I screwed the mounting plate with the access point on, and then obviously this is super flexible, so this can easily bend all the way around inside the access point, go up into the hole, and we get the AP on the ceiling. So let's go and do that, and then get the rest of the APs installed. So there you go, that's all three access points installed. We've got the one on the ceiling in the living room, one in the kitchen, and one on the upstairs landing. And realistically, they're not the prettiest access points in the world, but they don't look too bad. I think I might end up moving the kitchen one, just because I put it right above where you stand when you're cooking, and it's quite noticeable on the ceiling. It makes the ceiling feel quite low because it's right above your head. So I might move that more out towards the side of the room, but there's plenty of slack on the cable, so that should be completely easy to do. But yep, they're all installed and working perfectly. The only bit of advice I'd give for when you're installing these access points is, as I demonstrated earlier, to put them into CAPs mode, you need to hold down the reset button as you power it up. Of course, you only need to do that the first time you set it up, but if you're taking a bunch of APs out of the box and installing them, you probably don't want to install them on the ceiling straight away and then go and power up the switch, because then you need to go into each access point and hold down the reset button. The best way I found to do it is to get everything already connected at the switch end, so that when you plug the access point into the cable, it instantly powers up. That way you can plug the cable into the access point, hold down the reset button, get it into CAPs mode, and then clip it up onto the ceiling. So if you're doing a larger deployment, that's probably the way I would recommend doing it. In terms of performance, they perform exactly as I'd expect for a 2x2 Wi-Fi 6 access point with 80 MHz channels. If I'm in the same room as an access point with line of sight, I can easily get 600 meg down and 600 meg up, and I've even seen it go well beyond 700 meg, which is really, really good and exactly what you'd expect for this type of AP. Then, once everything was configured, I ended up making a few more configuration changes. The first one was that, as I mentioned, these will automatically pick their Wi-Fi channels. However, what I found is that they were picking sort of non-standard channels that would end up overlapping with other channels. For example, with 2.4 GHz, generally speaking, you tend to use channels 1, 6 and 11. There are slight variances between different countries and different standards, but generally, at least where I am right now, everything tends to use 1, 6 or 11. But out of the box, the APs, MikroTik APs were just picking random channels, channel 2, channel 5, just sort of not really lining up with the others. All you had to do though is go into the configuration, and then where you have the frequency option, you can add in all the frequencies of the channels that you want this to be able to use. So here I've added in the frequencies of channels 1, 6 and 11, and once I did that, it only picks those channels. And I did the exact same for 5 GHz. With 5 GHz, I also removed some of the higher frequency channels. I've noticed some weirdness with my MacBook Pro, that with some of the higher frequency 5 GHz channels, the MacBooks just won't want to use a full 80 MHz channel at those frequencies, even though those frequencies are meant to support 80 MHz channels. It's a little bit weird, and it's something I've found with other access points as well, but all I've done to get around that is just set it so it won't use those higher frequency channels, and there's still 4 channels available to use, which is absolutely fine. That said, this still isn't perfect. As I mentioned earlier in the video, these APs will automatically scan for channels when they first start up, and then also after this reselect interval. As I suspected when I talked about it earlier, when the APs first start up, they all scan for channels at the same time and really do have a tendency to pick the same channel as each other. Setting up the reselect interval, as I mentioned earlier, does kind of help to sort of slightly randomise the time that the access points scan for channels, but it doesn't seem to be perfect. And I have noticed that I've had situations where the access points have all been on completely different channels, and then the rescans happened, and then some of them have ended up on the same channel as each other again. I think the difficulty is that because the access points are installed around the house, potentially the access point can't see anything on that channel, or it can't really see the other access point on that channel, so it's fine that it'll pick the channel, but there is another access point there. So it doesn't seem to be perfect. I think in the end what I'm just going to have to do is bite the bullet and create a bunch of separate configuration profiles and kind of hard code different channels onto different APs. Realistically, it's maybe not super neat, but if you use a CLI, it's pretty easy to bulk edit these configuration profiles, so it's not going to be too bad. Then, as I talked about earlier, I'd already enabled things such as fast transition to make it quicker for devices to roam between access points. The only other configuration change I needed to make after getting everything set up was to lower the transmit power of both the 5 GHz and 2.4 GHz radios. Out of the box, these run at a full transmit power, and they're pretty powerful and easily extend throughout the whole house per access point. The problem with that is that roaming for Wi-Fi isn't dictated by the access points, it's dictated by the client. And if the client device is already getting a pretty strong signal from another access point, it just won't even try to roam. So in situations like that, especially if you're not got, say, a single access point you're trying to extend throughout your entire house, the best thing to do is significantly drop the transmit power. That way there's less overlap between the access points, and as you walk around the house with your device, the signal strength from its access points connected to it starts to drop down. That device will then want to scan for other APs and roam, and it'll potentially pick a stronger signal. So that's definitely something to do, is if you've got, say, multiple access points and your device just isn't roaming between them, try dropping the transmit power, and that can quite often help. Then the other thing I've done is I've also significantly dropped the transmit power of the 2.4 GHz, even more than the 5 GHz. Now the reason you might want to do that is, as you'd probably know, 2.4 GHz signals travel significantly further and through obstacles much better than 5 GHz signals. That means if you're sort of sitting a certain distance from an access point and you check the signal strength, you'll generally find that the 2.4 GHz radio is a much stronger signal. And this can also cause issues with roaming and trying to get devices to pick the 5 GHz band, because quite a lot of devices will see the 2.4 GHz signal being stronger, jump onto that band, even though it's a much more congested band and has a much smaller channel width. So by just dropping the transmit power of the 2.4 GHz radio significantly means that it's no longer seen as a much stronger signal. Devices tend not to prefer it as much, and where possible they will move to 5 GHz. But if I have a device that only supports 2.4 GHz, it'll still have no issues connecting to it. The key thing to bear in mind here is I'm not doing what some people do, where I'm treating 5 GHz as the short range thing and 2.4 GHz as the long range thing. I have plenty of coverage just on 5 GHz alone, and 2.4 GHz is purely for compatibility with devices that don't support 5 GHz. But yep, after dropping that transmit power down, making sure I had fast transition enabled and all the other sort of band steering and roaming features enabled, devices, generally speaking, are properly roaming. I can walk around the house and I can check on my phone and I can see it's definitely hopping to all the access points. It is working pretty well. It's not perfect, but that's pretty standard. Devices will sometimes stick to an access point a little bit, and potentially I might want to maybe move some of the access points around and things like that. But generally speaking, the roaming is working as well as I'd expect for any sort of multi-access point system. I think the only improvement I'd really make, which would also come under when I separate these configuration profiles out to hard code the channels on each access point, is after doing that, I would then also be able to set different transmit powers on each AP. Right now, because I only have 2 configuration profiles, the transmit powers apply to all the access points. Whereas what I actually would probably rather have is have the upstairs access point a bit higher power because it's in the centre of the floor and has to cover all the rooms. But then downstairs where I have 2 access points, I might want to drop the power of those slightly, just so I don't stick to each access point as much when I walk between the kitchen and the living room. So yeah, there's a few configuration changes I might want to make, but I won't go into that in this video. It's also worth mentioning that after my previous video where I had some sort of test network set up, I've now set this up with my main network where I have a single SSID and I'm using Multi-Passphrase for everything, and it's working perfectly. So yep, Multi-Passphrase works perfectly. All my old devices just connect these straight to the new access points without any issue. So yep, it all works absolutely fine, but there's definitely one key takeaway from this, and you might already be able to tell what it is, and that is that using Wi-Fi with MikroTik is not for the faint-hearted. It's quite interesting and it's a good learning opportunity. I've learned a ton more about Wi-Fi than I thought I knew before, just from the amount of research I've had to do to get all this working. But it really doesn't hold your hand. For example, you have to enter the frequencies rather than picking individual channels. You have to manually enable all the sort of roaming features. You then manually have to go in and set all the transmit powers. It doesn't do everything automatically. Whereas a lot of other access points like Unify, you can quite simply go in, tick the band steering button, tick the roaming button, and it'll kind of just optimize itself based on what it thinks is best for your setup. Of course, if you want to learn about Wi-Fi and experiment with it all, this is so much better. But if you just want access points that work and just want to set up a simple Wi-Fi network, setting up MikroTik is going to require a lot more learning and research, and it may not be something you're necessarily wanting to do. Of course, time will tell to see how reliable this is if I do actually run into any issues. As of the time of filming, I've only really been using these full time for a couple of days, so I'll continue to use them over the next few weeks, and when I come back with my final video in the series, we'll see how I get on. But yeah, so far, the access points work pretty well. Definitely takes a lot of research to set up, but now that they're up and running, they seem to work quite decently. So there you have it. That was a look at migrating my home network to run purely on MikroTik access points. So hopefully you found this video interesting or potentially useful if you've been considering MikroTik access points, and if you're interested in buying any of the hardware you've seen in this video or in this entire series, check out the links to them on the MSDIS store in the video description and in the pinned comment. And I'll also leave a discount code for MSDIS down there as well. But all I've to say now is thank you very much for watching.